Hi students, welcome to class. In the last lesson we talked about properties of polygons, and we looked at things like how do we name them, how do we know if they're regular, irregular, convex, non-convex, concave, if you will, and we even looked at how we can find interior and exterior angles. And that was for in general with all polygons. So for the rest of this chapter, we're actually going to be focusing on one subgroup of the polygons. We're going to be looking at the quadrilaterals, or the four-sided figures. And today's lesson is going to focus on the parallelograms. So in this lesson, we're going to prove and apply properties of parallelograms. We are going to use properties of parallelograms to solve problems, and we're going to use properties of parallelograms in proofs. So before we get into the lesson, I want to just give you a little helpful hint, just something to keep in mind as we talk about some properties of parallelograms, and that is opposite sides. So when we talk about opposite sides of a quadrilateral, they do not share a vertex. So they really have absolutely no points at all in common. And opposite angles do not share a side either. So they're angles that are across the figure. They're not formed by any of the same segments. So just kind of keeping that in mind, that opposite sides do not share a vertex, and opposite angles do not share a side. So what's the definition of a parallelogram? So a quadrilateral with two pair of parallel sides is called a parallelogram. To write the name of a parallelogram, much like we did with triangles, you would put a symbol in front, and we actually just draw a little parallelogram symbol. And that's kind of to distinguish. If we just put four letters down, just randomly, A, B, C, D, we'd know it's at least a quadrilateral. Kind of like when we saw three letters, it could be a triangle, but it also could just be an angle, so that's why we always put the little triangle symbol in front. If we have four letters, we know it's got to be some sort of quadrilateral, but we'll usually just draw the little parallelogram symbol so that we know that it's one of the figures that has opposite sides parallel, that is a quadrilateral. So ABCD is a parallelogram, and we can always tell a parallelogram by the markings on it, if it's got the markings. And we can see that there's opposite sides that are parallel. So AB is parallel to CD, and BC is parallel to AD. So this is a parallelogram. And if a figure is a parallelogram, then all of these properties that we're going to cover here are true. And so this is called the properties of a parallelogram theorem. So if you have a figure that it's a parallelogram, all these things are going to be true about it. The first one is, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So not only are the opposite sides parallel, but the opposite sides will be congruent. So we can actually add some markings to this parallelogram. Not only should the opposite sides be marked parallel, but they should be marked equal to each other. So opposite sides in a parallelogram are congruent or equal. Secondly, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Opposite angles are congruent. So yeah, we already said opposite sides. So not only are the opposite sides congruent, but the opposite angles are congruent. So you can see here in the diagram, these are marked congruent. The B and D, those are opposite. And then if we went on the other side here, we looked at A and C, those are congruent. So opposite angles are congruent, opposite sides are congruent. And let's see what else is true. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So remember the word consecutive means next to. So what it's saying is, if you were to take any pair of these angles that are next to each other and add them up, that we should always get 180 degrees. And that's what these statements say right here to the right. And now I'm just labeling them on the diagram as well. So any angles that are next to each other will be supplementary. And if a quadrilateral is a parallelogram, then its diagonals bisect each other. So we've got diagonals that are the segments that connect non-consecutive vertices, or non-adjacent ones. And so you'll see these here in the drawing, and AC and BD are the diagonals. And what it's saying is they will bisect each other. So in other words, that where they cross right here, that divides the segments up equally. So those two segments, AZ and CZ, would be congruent, and AZ and DZ would be congruent. And so they bisect each other. And it turns out that all of these properties came from triangle congruence, which is something we studied back a chapter or so ago. And if you were to take a parallelogram and draw in one of the diagonals, you could actually prove that the triangles that were created were congruent. And, you know, it doesn't matter whether you drew in that diagonal or say you drew in the other diagonal this way, you could prove that those triangles were congruent. And so that's where all these properties come from, because if you could prove, say, for instance, that those two triangles there were congruent, then, and you could do that using, you know, the fact that you've got parallel sides, so you've got some angles equal, like you could say, you know, this angle is congruent to this angle, they're alternate interiors. These two angles are congruent. They've got a shared side that we just drew in, that auxiliary line. And we could prove those triangles congruent using angle side angle. And so then that means all the corresponding parts would have to be congruent. So that would lead to the fact that then that means that these opposite sides would have to be congruent because they're the corresponding parts of congruent figures. The opposite angles would have to be congruent, and so on. And so what we're able to do is kind of work our way through all of this using triangle congruence to come up with all of these parts congruent, just knowing this, that we're starting off with opposite sides parallel and then using triangle congruence. So let's go ahead and turn the page. So the first learning goal really is just to apply these properties, to get to know them well, opposite angles, opposite sides equal, diagonals bisect each other, stuff like that, and see if we can use it to find parts in parallelograms. So we're told that this diagram here is a parallelogram, CDEF, and we're given this information. The segment DE, which is right up here, is 74 millimeters. And that DG, which is this little piece right here, that is 31 millimeters. And that angle FCD, so FCD, this whole angle right here, is 42 degrees. So then they asked me to find some parts. So I'm going to highlight the things they're asking me to find. So first of all, they're asking me to find segment CF. So here's segment CF. Well, notice CF is the side that's opposite the side DE, which we were told was 74. So according to the properties of a parallelogram, those would have to be equal, so it must be 74 millimeters. So what about B? It says find the measure of angle EFC. So let's see, EFC is this whole angle right here. Well, the angle that was right next to it, we were told, is 42. Remember that consecutive angles in a parallelogram have to add up to 180 degrees. So if we wanted to find this angle, we just have to take 180 degrees and subtract 42 degrees, which would give us 138 degrees. So that's this angle right here, 138 degrees. And again, this is the one we're finding, is this one right here, that whole angle. And what about finding segment DF? So here's DF right here. Now notice that is a diagonal. And they actually gave us part. They gave us from D to G. And so we were told that the diagonals bisect each other. So what we actually know in this drawing is that these two are equal, these two are equal. So knowing that what G is will allow us to find FG. They're going to be congruent, they're the same. And so I know that DF is actually the sum of that 31 and on both sides. So that's 31 times 2, which is 62 millimeters. All right, so what about example 2? So this time we're told this, again, a parallelogram. So we know all these properties about the parallelogram, and they want us to find the measure of angle Z. So that's this angle right here. They want the measure of angle Z. Well, in order to know what the measure of angle Z is, I need to find B. So I need to find B first. That's my step 1. Well, there's 2 places where you see B, and the first place is in this angle that I'm looking for, but then also right here. Well, those angles are consecutive angles, and that there was the property of a parallelogram that said those have to be supplementary. So I could use that fact, and I could write this equation that says 18b minus 11 plus 9b plus 2 must equal 180 degrees. And then I can go ahead and find the value of b. So I'll put my like terms together. That makes 27b. And then the minus 11 and the plus 2 is minus 9 equals 180 degrees. I could add 9 to both sides, which left me with 27b equals 189. And then, of course, divide both sides by 27. And that'll give me my value of b that I can use to find the angle measure. And that turns out to be b is 7. So let's see, angle z. So angle z is 9 times 7 plus 2. 9 times 7 is 63, plus 2 is 65 degrees, and so that's the measure of the angle I'm looking for. Well, next I want to find side WX. So here's WX, and the side that corresponds to it in that parallelogram is ZY, and they're supposed to be equal. So that's exactly what I'm going to say, is that 6a plus 10, which is what WX is labeled as, and ZY is labeled as 8a minus 4. So those are going to be congruent. And all I have to do then is just solve to find out what a is, and then I can plug it in to find that side. So if I were to subtract a from both sides, I could do that. Well, actually, maybe I'll do something different. Maybe I'm going to subtract 6a from both sides. I usually do move the smallest variable. And that's going to leave me with 10 equals 2a minus 4. Add 4 to both sides, and that leaves us with 2a equals 14. So that means a must be 7. So both a was 7 and b was 7. And that means that segment WX must be equal to 6 times 7 plus 10. Well, 6 times 7 is 42, and 42 plus 10 is 52. So 52 units of some sort. And so that is that side right here. There it is. Now, keeping the properties that we talked about earlier in mind, I'd like to make this one a you-try question. So I'd like you to pause the video now, take a look at the drawing, and see if you can find out the value of these variables and find the missing links that they asked for. So pause the video now. Okay, so go ahead and check out your answers. You should have found the value of W to be 4, so that the length of JG was 12 units long. And then in the example B, the value of Z was 4.5. And then when you plugged it back in to find that whole diagonal, FH, it turned out that each of the parts was 9, so a total of 18 for that whole diagonal. Okay, let's go ahead and turn the page. So we're going to go ahead and take a quick look at writing some proofs using properties of parallelograms. So taking a look at this first example, we're asked to prove that two triangles in this drawing are congruent. So the first thing I'm going to do is identify the triangles in question. So they want me to prove that triangle AEB, so that's this one right here, is congruent to triangle CED. So that's this one right here. So we're trying to prove that the blue triangle is congruent to that purple triangle. Well, ABCD, which is the figure that contains those two triangles, is a parallelogram. So this is going to give me lots and lots of possibilities for proving the triangle is congruent, because I know that I need to get 3 parts so that I satisfy one of those triangle congruence theorems. So I'm going to have to come up with a way of getting 3 pairs of sides, or a pair of sides and a couple of pair of angles or something. Come up with 3 that are congruent in these two triangles. So this is certainly not the only way to do it. This is just one particular way. So I'm going to start off by taking the idea that the opposite sides are parallel. So since these opposite sides are parallel, I could use the fact that we have some alternate interior angles, and I'm identifying a pair of them right now. So those that I marked on the drawing actually have to be congruent because they are alternate interior angles. So I'm going to write that as my second step. So I'm going to say that angle, let's see, BAC AE, and I'm going to say it's congruent to angle DCE. But there's actually another pair of alternate interior angles as well, so I'm going to put these in the same step so I can actually prove that these angles right here are also congruent. So I could say then that also angle ABE was congruent to angle CDE. And of course that's by the alternate interior angle theorem. Well, you might notice that there are vertical angles, and so you might have thought, oh, I'm going to go with the vertical angle route. And you could do that. We could have said that these angles here in the center are congruent and all that. But because I started this with this method and I've got these two angles, it's not going to do any good to find the third pair of angles because there is no angle theorem. So I need a side somehow. So there's a couple different pairs of sides I could go with too. So again, this is just one way. But I was thinking of side or segment AE being congruent to segment CE. And the reason why is we know that diagonals bisect each other, and so that's one of the properties of a parallelogram. So I could say that AE was congruent to CE, and that's actually properties of a parallelogram theorem, and I'm going to specifically state in parentheses that it's diagonals bisect each other. So diagonals bisect. So that way I know, I mean, there was lots of parts to the properties of a parallelogram theorem, but this way I know it's the one that's where the diagonals bisect each other. And so I can see from the markings that I have enough to prove that the triangles are congruent. And the way that I know that is the angle side theorem, because I have this angle, and then the side that's not between them. So that's the angle side theorem. So as I said, there are many ways to have done that same task of proving those triangles congruent, because, you know, we could have gone the route of using both pairs of segments that were formed where the diagonals crossed as being congruent, and then you could have used vertical angles. I mean, that was a way to do that as well. So this is just one of many ways to do this. To achieve this goal, which is to prove these triangles congruent. So keeping that in mind, because I know there's many ways to do this last example, rather than leaving it as a you try and then having to talk about all the different possibilities, we'll just go ahead and work this one together. So we've got the fact that these two triangles we want to prove are congruent, RSU and TUS, and this thing's a parallelogram. So we know that's what's given, and let's see, what are some things we could say? How about if we started off and we said, well, opposite angles are congruent. So we could start off saying that angle R and angle T were congruent. That's easy enough. And that's because of the fact that we've got opposite angles are congruent in properties of a parallelogram. So we could say properties of a parallelogram, and the actual reason is opposite angles are congruent. Now I've only got one more line, and I don't really want the table to kind of dictate the way we do it, but since I do just have one more line, I got to see if I can get two parts out of just one line. So that means if there's two facts I can say using the same property, and actually there is. I could say that these sides SR and UT are congruent, and because they're the opposite sides of parallelograms. But I could also do the same thing with ST and UR. And so I know that they're congruent because of the same properties of a parallelogram theorem, but a different part of it. It's the one that says opposite sides congruent. So I could just say opposite sides congruent, and now I've got the three parts that I need, and hopefully you can clearly see that the markings show side, angle, side. So we know the triangles are congruent by the side, angle, side congruence theorem. And well, that does it for today's lesson. So the practice on this lesson will involve doing things like finding parts of parallelograms and proving things using the properties of a parallelogram. So thanks for being with me in class today. I'll see you soon.